In a study that was just published a couple days ago, researchers found a system that consists of a red dwarf and a white dwarf circling each other. I have a short video describing the discovery, and then I want to go a little more in depth. My name is Cameron, and this is my channel. Welcome to the sexy universe. Shout out to Mrs. Stroud, 11th grade astronomy, who taught me that Antares, that big red star, is the heart of Scorpio. And the way to remember that is ants are creepy crawly and scorpions are creepy crawly. But just remember that big red star and that center of the galaxy right there. So there's Antares right there in the galactic center. And we're going to go to a little system called AR Scorpii. It was actually found in 2016. And it's a system with a red dwarf and a white dwarf going around each other. Well, this system wasn't found with optical telescopes, either ground-based or Hubble or the James Webb telescope. This is called MeerKAT. It's a whole bunch of radio telescopes based in South Africa. And the thing is, MeerKAT doesn't pick up optics, it picks up radio signals. So the question is, where were the radio signals coming from? Well, it turns out that white dwarf is spinning, and every time it spins, it pulses out some radio signals. And as it turns out, just like donkeys have layers, so do white dwarfs. So the outermost layers cool the quickest, and so they form a crust. And the inside is a little bit more fluid, so it spins faster. And just like the Earth's core creates a magnetic field, so can a white dwarf's. In 2016, when that was discovered, it was the only system like it. But as it turns out, another one very similar was just discovered, and it's even more interesting. So that red dwarf would be a type M star, and those type M stars are generally about half the weight of our sun, half the mass. And you can see in this chart from a 2007 survey that white dwarfs are generally about half the size of our sun also. And I've seen a lot of stories saying that the white dwarf is going around the red dwarf, but if they're the same mass, they wouldn't actually be doing that. Alright, so I made this model to scale, and if they're both the same mass, they'd be going around the same center of gravity there, which is the tack. This really is how big the white dwarf would be in comparison to the red dwarf. After they picked it up with radio telescopes, they went and pointed optical and X-ray telescopes at it too. This is a graph of optical data, and what it shows is that the two of them go around each other about every 4 hours. And this radio and X-ray data lets you determine the spin, which is about 5 minutes 19 seconds. But there was also a spike in that data, which shows an X-ray burst. And what that X-ray burst means is that material has to be coming off of that star and getting sucked up by that white dwarf as they go around each other. And that white dwarf is vacuuming it up and stripping off the electron. And that makes X-rays. If you're enjoying this video so far, please click the like button and leave any thoughts you have in the comments section, because it helps the YouTube algorithm. If you've got any questions you'd like me to follow up on, please put those in the comments section as well, and I'll get back to you as soon as I can. Okay, just a few things I want to go over real quick in this paper. First, I want to go over where the authors mentioned that this flare is caused by accretion. And what they mean is when material leaves the red dwarf and it gets consumed by the white dwarf, first those gases begin revolving around the white dwarf's surface. And as they're pulled toward that surface, they rotate faster and faster. That speed of rotation creates a lot of friction within the gas, and the gas heats up. It gets hot enough to become a plasma where the electrons have been liberated from their orbits. Those electrons then move freely, and they move very fast, sometimes at speeds up to 80 or 90% of the speed of light. Electrons moving that fast are called relativistic electrons. Those relativistic electrons then begin to move in streams, and those streams trace along ribbons of molecules that haven't lost their electrons. When they cross through a magnetic field, that magnetic field can slow them down. And in the process of slowing down, they have to lose energy. that energy is liberated as X-rays. So we can use this model of a black hole's accretion disk as a similar model for this white dwarf, except instead of having consistent accretion going on, it would be in pulses. And as a result, you wouldn't have a steady stream of X-rays, you would have pulses and flares, which is what we see in the observational data for this system. Because the accretion disk isn't a steady stream of material, but instead it's coming out in pulses, the researchers believe that the red dwarf is actually reaching a stable state where material is not going to continue to come off of it. If material kept coming off the red dwarf, the white dwarf would eventually become heavy enough to reignite fusion, and then the system would be destroyed in a type 1 supernova. But since steady accretion isn't going on, there's probably going to be a different ending to this system. The white dwarf's temperature is consistent with a crystallizing core. And as the core crystallizes, the magnetic field becomes steady. That steady magnetic field spins like a gear. And some of that rotational energy is transferred to the revolving system of the red dwarf and the white dwarf. And as they speed up, the distance between them becomes larger and larger, until eventually they're far enough apart that gravity is no longer sufficient to hold the system together. At that point, the red dwarf and white dwarf will fall apart. And that will be the end of this system, even though the two objects themselves will continue to exist. And they use that frequency of 2, along with the volume of space they were discovered in, to set a lower limit on the frequency at which systems like this can exist. And since we know what patterns to look for now, they should be easier to find. That's it for this paper. If you've enjoyed this video, you may enjoy one of my others. Please leave any thoughts you have in the comments section. And I'll see you next time on the Sexy Universe.